Today we're learning the next two ways to prove triangles congruent without having to prove all 6 pairs of corresponding sides and angles are congruent. This first one, and I'll apologize real quickly, this should be the angle side angle congruence postulate. It's not a big deal. We're not going to make you differentiate between which ones are postulates and which ones are theorems. It really doesn't matter a lot to us in this unit. So this says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Notice the side has to be, in both cases, in between the two angles. It has to be the side that runs from the vertex of one angle to the vertex of the other angle. It has to be, that's the included side. And that's why it's called angle side angle, because the side is right in between the two angles. Right? This side is in between these two angles. Okay? So that's angle side angle. We also have angle angle side. Now this one is a theorem because we can prove it based on angle side angle. I'll explain in just a moment. But on these, we have two angles and the non-included side, one of the non-included sides, it doesn't matter which one, of one triangle congruent to the corresponding parts of another triangle, then the triangles are congruent. Notice here, is this side in between the two angles? No, and that's why we call it angle angle side. Now, when you're doing proofs, if you decided, I don't want to use any theorems, I'm only going to use postulates. Okay, you could do this one by going, okay, if these two angles are congruent to these two angles, what else do I know? The third angles are congruent. So I know that Z is congruent to L, and then I could use angle side angle. It would make your proof one step longer. But again, mathematicians being really, really lazy, they're like, nope, we don't want to do one extra step. We'll create a whole nother thing so we don't have to do one more step in our proofs. It's pretty lazy. All right, now, there are two combinations of 3 parts, sides and angles, that cannot be used to prove triangles congruent. And I'm going to show you an illustration of why. The first one is angle, angle, angle. If the angles are all the same from one triangle to the other, do the triangles have to be the same size? No. And that's why angle, angle, angle cannot be used to prove triangles congruent. Later on, we'll talk about similar triangles. Those two triangles are similar to one another. They're the same shape, but not necessarily the same size. The other one that we cannot use is side-side angle. And that's because I could have drawn this same triangle again and it would match up, but imagine, if you will, taking this side and just kind of swinging it out this way. See how you get this other triangle, which doesn't look at all like the original triangle? I haven't changed either of those two side lengths or that angle, but I've made a completely different triangle. So sometimes side-side angle gives you congruent triangles, but sometimes it doesn't. So because it doesn't work all the time, we can't use it. Okay? So let's do some proofs. And we'll do this one as a flowchart proof just for the fun of it. If you're absolutely opposed to flowchart proofs, you can do it as a 2-column. So here, we're given that angle R is congruent to angle S. And then we're also given that O is the midpoint of segment RS. That's also a given.
Wait, which one do you box up?
Oh, sorry. Yeah, you box the reason. All right. So if O is the midpoint of segment RS, I should be able to make a conclusion based on that. What else then do I know? If O is the midpoint, yeah, then RO, segment RO, is congruent to segment OS. How do I know that? Yeah, that's the definition of a midpoint. Why do I keep trying to box my statements?
So you always box out the
No. Usually you box the statements. I don't know why I switched them.
Okay, that's what I thought. And then you switched them, and then when I asked you when you did the second
And I was like,
time-
no, I made a mistake, and then I fixed it backwards.
No need to yell so much.
So yeah, I'm sorry. My fault. We boxed the statements, not the reasons. All right, so I've used the two things that I was given. Is this enough to prove the two triangles congruent yet? No, you always need three things, right? You've noticed that side, 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 angle, side, angle, angle, side. So I've got to get something else, which means it's got to come from the diagram. What is it that we can see in the diagram that we know is always going to be congruent? Vertical angles. So these two vertical angles have to be congruent to each other. Angle FOR is congruent to angle TOS. How do I know that? Yeah, vertical angles are congruent. Now we have enough things to prove the triangle's congruent. So I'm going to bring those three things together. And say that triangle FRO is congruent to triangle TSO. And which of the four shortcuts am I using here to prove those triangles congruent? Yeah, angle, side, angle. Because the side is in between the two angles in each of the triangles. I kind of like flowchart proofs for the shorter congruent triangle proofs. Later, when they start to get long, it can get kind of messy. But one of the things I like is I like telling people you've got to have three things that come together to prove the triangle's congruent every single time. And in fact, once upon a time, I used to make people, when they did a two-column proof, they had to tell me which three statements they used to prove the triangle's congruent. Right? Give me those numbers. I don't require that anymore, but I could. All right. I'm sorry? I'm hearing parts of it, but not all of it.
It should be.
It should be AT.
That's what she's saying.
Thank you. I remembered that there was something wrong with this. I just didn't remember what it was. So yeah, it needs to be AT bisects angle CAF. All right. We'll do this by show of hands. Two column or flow proof? How many would like to do 2-column? Well, that's over half the class already, so sorry for those of you who like flowchart proofs. If you want to do it as a flowchart proof, do it as a flowchart proof. So a lot of given, but nothing congruent yet. I'm going to need 3 things that are congruent. So let's start at the beginning. If AF is perpendicular to FT, what do perpendicular lines make? Right angles. Those two meet at F, so that's a right angle. And AC and CT meet at C, so those two are a right angle. So angle F and angle C are right angles. How do I know that?
Definition of perpendicular lines.
Exactly right. Definition of perpendicular lines. I was given perpendicular lines, therefore I know I have right angles. That's what the definition of perpendicular lines says. Have I said that those 2 angles were congruent yet?
No.
No, so I need to. Angle F is congruent to angle C. We've said this multiple times today. That's because all right angles are congruent. So I've used these 2 parts of the given. I haven't used this part yet. AT bisects angle CAF. I haven't used an angle bisector in a while. What does an angle bisector do to an angle? So I'm sorry, I'm hearing 2 or 3 things at once, and my brain won't do it anymore. Once upon a time, I could do it. What did you say, Lexi?
Splits it into 2 equal parts, segments.
Not segments,
Angle.
and not equal.
Congruent.
Okay, congruent.
Same thing. You knew what I meant.
Sort of. Yes, I did know what you mean, but I'm hoping to get you to where you say what you mean.
Not mean what you said.
Yeah. So AT bisects CAF, so it's going to divide CAF into 2 smaller angles that are congruent to each other. So angle FAT is congruent to angle CAT.
Could you do that in any order as long as they're like
Could I have called it TAF and TAC? Is that what you're saying?
no, like could you do like AFT and ACT?
No, because AFT would be angle F.
Oh.
Remember, the middle letter tells you the vertex of the angle. F is on one side of the angle, A is the vertex, T is on the other side. This is because of the definition of an angle bisector. Again, we have gone through all of our given, and we still don't quite have enough, so we have to get something from the diagram. What is it in the diagram that we know is true no matter what?
Segment AT is congruent to segment AT.
Yep. Segment AT is congruent to segment AT. And that is the reflexive property. Well, now I've got 3 pairs of congruent things in my triangle. That should be enough. How can I prove my two triangles congruent?
AAS.
Yeah, angle, angle, side, because the side is not between the two angles.
Suspect that.
You're just now getting that?
No, I just wanted to say that.
Pardon?
I just wanted to say that.
Okay. A lot of times, my congruent triangle stuff, when I write them, you'll see when you do worksheets and stuff, they spell things because I get bored otherwise.